So I want to check to make sure that it's, you know, within with the length of this vise. So if you put a longer piece on there, it exaggerates the error at the ends of the piece. So that's why I put a longer piece in here. Any error becomes apparent. In the spindle, a super sensitive dial, it's called a DTI, dial type indicator. The probe, I'm going to touch against the edge of the aluminum bar here. You can see the little probe, and you can see the dial move. You see that? When I move the probe. And that's, man, that's super sensitive. From here to here is 5,000. So it, you know, any slight variation is going to show up on this dial. I'm going to run the y-axis out towards me until it just touches and makes that probe move. Oh, there it goes. I know I've got tension on that now because it's I had it on 0. I'm going to move it out to like 2 thousandths. And now I'm going to traverse the X. Let me zoom out. I'm going to traverse the X out to this side and see how much out. And this will tell me, this is tight in the jaws of the vise. This will tell me if the vise is angled at all. So this vise, you can rotate it on its mount. The mount has a scale on it, you know, marked in degrees, so you can rotate it. Of course, it has a 0 mark, but it's pretty crude. I went ahead and just locked down the hold down bolts, but I loosened the nuts that allow the vise to rotate on its mount, and that makes sure it rotates right in the center. And I reset the 0 in the middle here, and now I run it out, and I got about 5 thousandths of run now between the center here and 4 or 5 inches out. So I'm going to run it across and show you. Now the needle is so sensitive that it will, if you drop the piece of metal or drop something on it, or there's a piece of a scratch, you know, it'll show those scratches up. So you'll see it bounce as I move across. That's how sensitive it is. But it almost stays within a half a thou. All the way across now. And I'll tighten it down and check it again. Look at that. And that's what you want. And believe it or not, I built my first 2 engines that I ever built. I never did this. I didn't know this was a thing. I didn't know what I didn't know. It's unknown. But boy, does it help when you do this and your stuff starts coming out looking really, really good. And working better too. Now I tightened it. Now, almost always when you tighten it, it changes, because just the act of tightening it, the torque you put on the nut. So I'm going to reset the 0. So just that act of tightening it changed it that much. So I'm just gonna loosen it a little bit now. As I went that way, back to the 0. I'm gonna go about halfway. That's pretty much dead on. Within a half a thou. Now when I tighten it again, let's see what happens. There's a half. It will wiggle because, you know, the bar itself has got nicks, dents in it. That's really good right there. I've gone way out. So as you can see, this takes some time, and it's fiddly. So I'm going to call that done. Dialed in the vise. The reason that I dialed in the vise just now was because I have to cut this little groove in this is called the face blocks. The face block that holds the cylinder. Ultimately, this is where the cylinder slides back and forth on the opposite face block, which I will call the valve block. As you can see right here. Now these showed 3/4 inch brass, so I had a piece of 1/2 inch, and that the cylinder is only 1/2 inch. So I didn't see any sense in ordering the metal for 3/4 for this one. I wanted to just get one done. So I had some 1/2 inch. So I marked it out on the surface plate with the height gauge for the groove there, and that groove will center the cylinder on the plate and hold it, and it'll hold it while I solder it in place. So if I didn't have the vise, I'm going to hold this in the vise while I cut it with a 1/4 inch cutter. If I didn't have the vise dialed in, this would could cut across here at an angle, and that wouldn't be any good. So it's a kind of small piece. I'm going to zoom in here so you can see what I'm doing. So here's the big picture. I'm on my Inco mill, the Inco knee mill, with the mill vise dialed in so that as I traverse across the vise from one side to the other, it's within 1/2 thou accuracy, so that this slot that I cut will be straight relative to the edges of this cylinder face block. That's going to go right at the top of the cylinder, and that little groove there will hold it while I solder it. On this Inco, I got to drop my drill chuck out and put in a 1/4 inch end mill. There's a 1/4 inch end mill already in my R8 mandrel. R8 is the taper. I have several tools already set up. I have 3 of these R8 mandrels, 4 of them. So you can just change them out real quickly. There's a screw up on that goes through the top of the spindle. The screw's got a bolt on it, and you tighten the bolt, and that pulls the mandrel up tight, and it mates with that taper, and it's perfect. Now, in a factory or a machine shop, they'll have an air changer. They could step on a pedal, it releases this out, boom, pop in a new one, take your foot off the pedal, and clamp. It's in there, boom, that quick. Because when you're making 1,000 parts, if you can save 30 seconds on each part, that's a lot of time. And of course, in a CNC operation, they'll have an automatic tool changer that just does it automatically as the program dictates. But I'm kind of old-fashioned here, because as you get fancy like that, the money, it gets more expensive. So I'm bringing up the table on the Z-axis. I'm bringing it up, and I got 2. These are Inco parallels. This is a 1/8 inch. These are pretty typical 1/8 inch parallels. 1/8 by 1 1/4 by 6 inches. They're pretty standard, and you can buy these. They're not real expensive, and they're really handy to have when you're doing setups like this, holding things, getting things true and accurate. So I have the parallels in there. As you tighten, in a vise like this, it tends to lift. All right, so what you do is boom this down while I tighten it up, and I can see it's tight because you can't move the parallels. That means that the piece is jammed down against the parallels. Safety goggles on. Zoom you in a little bit so you can see what's going on. Got my handy dandy little cutoff brush. Five thousandths. let's see how that does. Now here's the cylinder. I could go another couple thou. All right. Take a pass without changing anything. A little bit more. 1,000, 2,000, 2,000. Okay, so this is what we got. There's the finished channel in there. Here's the cylinder, 1/2 inch by 3/8 inch bore. Go this, milled out to the contour of the cylinder. So I guess you could take a 1/2 inch end mill and go down here somehow. But that just gave me an idea. But maybe I'll do that on the next one. For this prototype, this is going to be good. You see that holds it pretty good. All right, we're back at the surface plate. I thought I would show you how I'm going to lay out the next face block. So here's the small ones that we just made, and these will fit on here like this and rotate. But since I'm making 2 of these, I got to make another one of these. So these were pieces of scrap metal that I had cut off when I was making another engine. I found this nice piece of 1/8 inch brass bar stock in my cutoff box. So I'm going to lay this out the exact size that's shown on here, which is 3/4 by 1 inch. Colored this in. It had some Dykem on it, but I just colored it in with the good old Sharpie. I got a lot of these cutting tools. You know, most any shop will have cutting tools. So the cool thing is these things measure. Look at that, 75 3/4 by 3/8, and you can use them. You can use them as parallels. Whatever you need. I guess if you had a big enough lathe, you could use them as your cutting tools. But these are so handy. I use them all the time. So I'm just gonna. I need a 3/4 inch piece by 2 inch pieces, 3/4 inch wide. So I'm just gonna lay that up against there like that, and scribe a line. Easy, super quick. Bing. Is right there. Another way you could do that is the 1, 2, 3 blocks. I use these a lot. You heard me talk about these before. They're 3 inches by 1 inch by 2 inch. So if you need to mark 2 inches, you just get this. Bada bing, bada boom. Look at that. 2 inches. Exactly. The engine, these parts will show, so you want these to look good. Now I can use that mark with my 1 inch block and come over here, line this up over here, so there's my 3/4 by 1 inch. and I'll cut this out on the bandsaw. Let's go over to the bandsaw and we'll cut this out. I bought this thing, and then since I moved here, I put a big wheel on here to slow this blade down to about 900 feet per minute. So that slows it down so I can cut metal. And then I bought this blade, was like 40 bucks. But this blade has been in here for 10 years. And since I'm just, I'm not a production shop, but you can cut with this blade. It's a bimetal blade that I got at the machine shop. Most machine shops will make up a blade for you. It's a 105-inch blade on this saw, and $40 or $45, it's lasted so long. It'll cut. I have cut 1-inch steel, 1-inch cold rolled steel with this, or 3/4 inch cold rolled steel. It'll cut it no problem. A few years ago. Now you can do this with a handsaw. If you have a sharp blade on a handsaw, you could do this with a handsaw. It wouldn't take that long if you had a sharp blade. Now, of course, I cut outside the line. Save the line, as my tool and die maker friend used to say. When you're cutting that, save the line. That way you have somewhere to go. You have something to follow. If you save the line, you can come in with the sander, the grinder, or the mill and cut it right down to the line. You split that line in two. That line's usually about 2 thousandths thick. You come in and you can... If you got good eyesight and you have your cheaters on, you split that line and you're within a thou. Well, that's pretty good for most work. I was looking at the plans. They do have this little rounded cutout here in the drawing for the face blocks. This is the block that holds the cylinder right here. And since there's not a lot of information, there's no instructions, and these are they're not fully dimensioned. I pulled out this old Mamad steam tractor on the shelf that I bought years ago. It has an oscillating steam engine on it. It does have it's dark. There, you can see it. You can see the cylinder. Well, that plate there is curved, cut to the diameter, partial diameter of the cylinder right there. So I was going to copy that, and I figured out a way to do it while I was cutting the other one I did right now. I'm going to cut this little curve in here like it shows on the plans. And you can also see, look how this face plate for the cylinder is barely bigger than the cylinder itself, whereas the one on these plans it's 3/4 of an inch, and the cylinder is only a half, and there's no dimension on the cylinder. So there's that little curve there. You can see the curve. I have it set up, marked them 1 inch by 3/4. As I showed, and then I just filed them. I just took a rat file, put them in the vise, and brought them to the line. I mean, they don't have to be perfect, but these are pretty square. I used a square to make sure I had the lines. So now I'm going to cut the groove. I've got a 1/2 inch end mill in here. I used an old cutting bit in here just to stand the part up, and I used a square, a little machinist square, to get it vertical. I centered the cutter over the center here, and I'll just take it in. I'm only going to take it in a 1/16 of an inch. See, I have the center line marked on here. That's as close as I can get it to focus. I have the center line marked. I got a 1/2 inch end mill in there. I'm going to touch it off on the face and then bring it in 1/16, which is 0.0625. A piece of notebook paper is usually about 3/1000. And what you do is you just drag it across there until it slowly shed it until it rips the paper. Then you know you're 3/1000, or until it holds the paper. Alright, so there's 3/1000. I know I'm 3/1000 away from the surface, this surface of this plate. 1, 2, 3, and 0, the hand wheel. I'm going to go down the whole face here, so I left a space. I left a 3/4 inch space down here, or 1/2 inch space, to get, so I can go right down. I can plunge all the way down. Safety goggles on. This is at an angle. It's going to be, your trench is going to be shallow at one end. It looks pretty good. Alright, 0.62, so take 10 off the start. Don't have to be that high. See how that looks. Okay, that looks pretty good. It's pretty even. Once I break my setup, the game's over. There it goes. So let's bring it over here in better light. Here's the before and after. Here's a cylinder. I cleaned this up off one of my other little steam engines that I botched. Look at that. Looks like it was made for it.